Hi there, we're going to take a look at the reciprocal functions of cotangent, cosecant, and secant. We're going to start with cotangent. All of these functions are reciprocals of the three main trig functions. So starting with cotangent, cotangent is equal to 1 over the tangent of x, which means on my graph for tangent, every place that the tangent is 0, it will be undefined for cotangent. So the first thing we need to do is see where those values are. Okay, so here you see in blue the graph of tangent, y equals tangent of x. Now we know we have asymptotes at the multiples of pi over 2, 3 pi over 2, and so forth. The period for tangent goes from negative pi over 2 to pi over 2. It goes uphill, left to right. So now what we know about reciprocals, we've just talked about the fact that for our cotangent graph, every place tangent equals 0 and crosses the x-axis, that's going to be where the asymptotes are for cotangent. So let's draw those in. Okay, here's our new asymptotes. Every place that tangent crosses the x-axis will become an asymptote for cotangent. Now I'm going to put some points on the tangent graph and we will graph their reciprocals for cotangent. So what you see here, these green dots, they just represent values of the tangent function. And I picked them because I'm interested in what their y-coordinates are. For example, this one is 1/2. The y-coordinate here is 1.5, which is 3/2. The y-coordinate here is 3. The y-coordinate for this one is -2. And the y-coordinate for this one is -1/2. Now, I'm going to graph some dots that will represent the reciprocals of these y values using the same x values. Okay, so if you look at this, for this x value, the y value is 1/2. So the reciprocal of 1/2 would be 2. For this point, the y value is 3/2. The reciprocal of that is 2/3. That would be this value. Up here, the y value is 3. So using the same x-coordinate, if I take the reciprocal, I'm at 1/3. Over here, the y value is -1/4. Well, the reciprocal of -1/4 is -4/1. And here, the y value is -1/2. Or excuse me, here, the y value is -2. So here, the reciprocal of -2 is -1/2. So you see a new series of dots, and let me show you what it looks like when we connect them. So whereas where the tangent function is rising, the cotangent function is falling. Instead of the tangent function going from negative pi over 2 to pi over 2 for a single period, we now have cotangent going from 0 to pi to complete one period. Now the period for both is pi units long. It's just that when we consider the period, we want to consider one complete branch of it. So we go from negative pi over 2 to pi over 2 if we're looking at tangent, that's the blue graph, and we go from 0 to pi if we're looking at cotangent. So tangent graphs go uphill left to right, cotangent graphs go downhill left to right with asymptotes at multiples of pi. So here you see the graph of just cotangent. It's going to cross the x-axis where our tangent graph had asymptotes, and it's going to have asymptotes where our tangent graph crossed the x-axis. Okay, so here's the summary for cotangent. We know the period is pi units. One cycle is going to go from 0 to pi. Now notice I don't have an equal bar under here because of the asymptotes at 0 and pi. There's no amplitude. We're going to talk about that in a second. One cycle goes from 0 to pi. There's a vertical asymptote at all multiples of pi because that's where cotangent is undefined. The domain is all x's that are not multiples of pi, and the range is all real numbers. I do want to take 1 second and take a look at this amplitude issue here because there is no amplitude, but the number in front of the tangent will give us some important information. So let's go back to our graph. If our graph is y equals 1 tangent x, then that means at our halfway point between our asymptotes, we are crossing the x-axis. At the halfway of the halfway, which means a fourth of the way, I'm up at 1 because 1 is the number in front of tangent. And I'm down at negative 1 at the other halfway point because 1, again, is the number in front of my tangent. So let's compare that to another graph. If you look at y equals cotangent x, there's an implied 1 there. So that means at my halfway marks at pi over 4 and 3 pi over 4, I'm up 1 unit and I'm down 1 unit. For y equals 2 cotangent x, at my halfway points of pi over 4 and 3 pi over 4, I am up 2 units and down 2 units. And for y equals 3 cotangent x, at pi over 4 I'm up at 3, at 3 pi over 4 I'm down at negative 3. So even though these functions, cotangent and tangent, do not have amplitudes, the number that you see that's a coefficient, 3, 2, and 1, that determines the steepness of the graph. So you are still going to use that number as you graph, but you're not going to call it the amplitude because it really is not. Okay, let's move on to the graphs of secant and cosecant. Sine and cosecant functions are reciprocals, and cosine and secant functions are reciprocals. So that means where one of the functions is 0, its reciprocal function is going to have a vertical asymptote. And where one of the functions has a relative max, its reciprocal function has a relative min. And every y-coordinate for one function will become its reciprocal for the reciprocal function. So let's start by looking at the sine curve and discovering what the cosecant graph might look like. Okay, here is the sine curve. Now you'll notice that it crosses the x-axis at negative 2 pi, negative pi, 0, pi, 2 pi, and so forth. So our asymptotes are going to end up being at those positions. So I'm going to have an asymptote at negative pi. I'm going to have an asymptote at negative 2 pi. I'm going to have an asymptote at pi and at 2 pi and at 0. I'm going to have all those asymptotes as part of my cosecant graph. All right, now we need to look at the different points. For example, this point has a height of 1. Now the reciprocal of 1 is 1, and so that point will be part of both graphs. Similarly, let's pick another value. So let's say I look at right about here. To me it looks like that y value is 1/2. The reciprocal of 1/2 would be 2. So the same x value would have the y coordinate of 2 for my cosecant graph. All right, let's add another point. Okay, I've put a couple other points on the sine curve. This one looks like it has a y coordinate of 1/4. So if I take the reciprocal of 1/4, I get 4. So this must be way up here. This looks like 3/4. The reciprocal of 3/4 is 4/3, which is 1, and 1/3, which is, about there. If I continue to do that, I am going to get a graph that looks like something like a parabola. It's going to be curved. It's not a parabola, but it is concave up. So let me show you what it looks like when we get them all on there. What happens is what I get in green are all of this reciprocal values for what I have on the sine curve in orange. And the same is true here. I take all of these y values and I graph their reciprocal values and I get these. So these are going to be rough sketches. When you graph these, you need to graph the sine curve first. They will have one point in common, and that will be at the top of each of the humps and at the bottom of each of the humps. Those are the only points that they have in common. Then you're going to draw your asymptotes, where the sine curve crosses the x-axis, and then draw your cosecant graph, and that's sufficient. Okay, here we have the cosine graph, and in order to draw the secant graph, the first thing I need to do is draw asymptotes where my cosine graph crosses the x-axis, because since secant is the reciprocal of cosine, when cosine equals 0, I get an undefined quantity for secant, so that's an asymptote. Then I'm going to do the same thing I did with the sine graph and cosecant. They will have a few points in common. The high points and the low points they will have in common, and then I will graph the reciprocals of all of the values. And here's what it looks like. It's the same looking graph that we had for cosecant, which is not a surprise because sine and cosine look the same. They're just shifted from each other. So the graphs are going to be very similar in the way that you graph them. Graph the cosine or the sine function first, and then draw your asymptotes and sketch the cosecant or secant graph. Okay, we're going to do I'm going to show you one example that kind of puts everything together for the reciprocal functions. If I'm asked to graph y equals negative 2 secant 4x plus pi and then plus 2, what I'm going to do first is graph the corresponding cosine function. So to do this, when I look at this, I notice that I've got a negative 2, which tells me a couple things. It tells me the amplitude is 2, and it also tells me that the graph is going to be reflected over the x-axis, which means, in essence, upside down. The period is what I get when I take this number right here, and I take 2 pi divided by that number. So in this case, I get pi over 2, so that tells me the period is going to be pi over 2. But I do need to know where it starts and stops. So the easiest way to do that is to set your 4x plus pi, that's my argument, to sandwich it between the ends of the period for the normal cosine function, which is 0 to 2 pi. If I solve for x in the middle, that will tell me where my cycle starts and stops. So I'm going to subtract pi, then I'm going to divide by 4, and my graph should be going from negative pi over 4 to pi over 4. So let's graph that first. Okay, before we can graph y equals negative 2 secant x of 4x plus pi quantity plus 2, we have to graph the corresponding cosine function. Now, in this cosine function, I know that the amplitude is 2 because of this number right there. I know that the vertical shift is 2 because of that number right there. I know that it's reflected over the x-axis because of the negative sign. I also know that my period is going to go from negative pi over 4 less than or equal to x less than or equal to pi over 4, because we calculated that on the previous slide. Okay, so that means my period, if I need to know that, my period is going to be pi over 2. Alright, so what I need to do is to put my 5 key points on. So I'm going to be going from negative pi over 4 to pi over 4. Now, normally in cosine, we're up at the top at the both ends, but because it's reflected, we're going to be down at the bottom. But before I even start doing that, I need to take into consideration this vertical shift. If I have a vertical shift of 2 units, that means my oscillating line is now going to be the line y equals 2 right here, instead of y equals 0. Everything is shifted up 2 units. So I'm going to have to use this as my oscillating line. So normally my first point would be up 2 units. It would be up at the top at both ends, but because it's being reflected over the x-axis, I need to go down 2 units on the endpoints. I will go up to the top, which is 4 because it's 2 units above, and then halfway through I'm at my oscillating line, and halfway through I'm at my other oscillating line. So let's take a look at what the cosine function is going to look like. There you have the cosine function that corresponds to this equation right here. Now, I'm going to make that dotted because I'm going to make it orange, and I'm going to make it dotted because it actually doesn't count as my secant graph. Now, if you notice, every place that my graph crosses the oscillating line for secant, I'm going to need to put an asymptote there. Okay, here you see I've put asymptotes every place where my graph crosses the oscillating line. They do not go where it crosses the x-axis because my entire graph has been shifted up. Now, once you get your cosine graph correctly placed, all you have to do is make every high point and every low point a point of your secant graph, and then draw the rest of the curves. So it would look like this. Every high point is a common point, and every low point is a common point, and then you draw the graphs to hug the asymptotes. And if I take off the cosine graph, you end up with this. Okay, here's your summary. I've got y equals cotangent of x. My asymptotes are going to be at multiples of pi. The graph is going to go downhill left to right. Right in between the asymptotes you will cross the x-axis. Halfway you will be up at the, not the amplitude, but the number that's in front, if there is one. And then you're going to draw a smooth curve. The graph of cosecant is going to be based on the sine curve, the sine graph. Every place it crosses the oscillating line, in this case the x-axis, you're going to have an asymptote. They have common points at the high and low points, and then the graphs, each section will hug the asymptotes. For the secant graph, you first draw the cosine graph using your 5 key points. Then wherever you cross the oscillating line, you draw asymptotes. So in this case it's at multiples of pi over 2. And then you draw your curves using the high points and the low points of your cosine graph and your asymptotes. Alright, there you have it. Cotangent, cosecant, and secant.